Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 9.5. This is number 7, and it says solve the system using Cramer's rule if possible. So let's see how we go about solving this. So the first thing is we want to put both of these equations in standard form. Standard form is ax plus by is equal to c. Basically, we put our x's first, our y's next, and then our equal sign, and then our numbers or scalars, constants, on the other side. So for this first one here, if I subtract y from both sides, I'm going to get x minus y is equal to 3. And for the second equation, that's already in the standard form for us. X plus y is equal to 5. Now we can actually solve this really easily by elimination by addition or even substitution. But we want to learn Cramer's rule because Cramer's rule is good for larger matrices, especially like 3 by 3 matrices. All right. So first of all, I want to copy in the formula for Cramer's rule here. And why is this not? Let me delete that. Try it again here. There we go. So here is the formula. And what it's basically saying is that for the system of equations, we're going to use the determinant of D. We're going to find the determinant with little subscript x there and determinant subscript y there. And if D is equal to 0, then the solution is, then we can't find it. And that's basically the determinant of our main matrix. So what we're going to end up doing here is we are going to go ahead and we're going to set this up in the matrix form here. So it's going to look like this. So it's going to be x minus y. So that's 1, negative 1. And then we'll close that one off. So this is going to be our matrix A here. This next one is 1 and 1, 1 and 1. And then the solution column can just look like this, 3, 5. All right. So what we're going to end up doing here is first finding the determinant of this matrix right here. And that is going to be, give myself a little bit more space here. So the determinant of, we'll call that one A, determinant is equal to 1 times 1 minus 1 times negative 1. So that's going to be 1 times 1 minus this diagonal here. So that's negative 1 times 1. And that's how we find the determinant here. So this is going to equal 1 plus 1, which is 2. So the determinant of our main matrix here is 2. And what that means is that we can use the Cramer's rule in order to solve this. If it ended up being 0, that means that we could not use Cramer's rule. So if it's 0, we can't use it. And that also means that the determinant is not invertible. But if it's not 0, if it's anything other than 0, then we can use it. And that means we can. And the reason is because if you notice that we're dividing by D for both of those values there. So it's important that we don't divide by 0. All right. So now we're going to say we need to find the derivative of d sub x. So let me write this up here. So d sub x. And what we're going to do for that one is we're going to, not the derivative, determinant. We're going to go ahead and replace our x column here with our resulting matrix there. So that becomes a 3, 5. And then we're going to use the normal column here. So that'll be a negative 1, 1. Negative 1, 1. And for dy, we're we are going to replace our y column with the 3, 5 this time. So that's replacing the y column with the 3, 5, and we're going to keep the x column the same as our original matrix here. 1, 1. All right, so this one is going to be 3 minus negative 5. So 3 minus negative 5, and that's going to equal to 8. And this next one here is going to be 1 times 5, so that's 5 minus 1 times 3, which is 3. So 5 minus 3, which is equal to 2. And then finally, we're just going to put our x and y into this formula here. So x is equal to dx, which is 8, divided by d, which we calculated at 2. So x is equal to 4, and y is equal to dy, which, remember, that's why we substitute the y column with the C, or the resulting matrix. So dy is 2 divided by the d, which is just the determinant of our main matrix, 2. So 2 over 2 is equal to 1. And that is our solution. And we'd answer with the 0.41. 4, 1. All right. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.